So welcome to Hardening Applications with Property Tests. When I submitted this, I didn't really know what the time constraints were going to be, and it refined a little bit after that. So we're going to change it to hardening a library with property tests, just to constrain it a little bit. So as mentioned, I'm Parker Selbert, known as Søren2 on GitHub, Slack, Twitter, all those kinds of places. That's my wife on the left, and together we make up Søren. And I've also worked with DScout, which is a company in Chicago, for almost 10 years now. And we started at DScout running Ruby with a lot of background jobs. Now, the way that it happens to go there, there's a lot of media processing and other things that are very suited toward heavy background job loads. And as we started moving from Ruby over to Elixir, we needed to have an interop between the two things. And so that led to porting Sidekick, the really popular Ruby framework, to an Elixir library named Kick. And there was a lot of complexity in that. There's all kinds of threading issues and race conditions and possible shutdown scenarios. And so as we started adopting it and moving more and more things over to it, we started finding bugs in staging and in production. And so we did our diligence and went through and fixed what we could, added new examples to squash any possible regressions. And that worked out pretty well, and it ran in production, but there were still some lingering bugs that were just really hard to track down. And around that time, Redis came out with a new feature. So Sidekick is built on Redis, also built on Redis. It came up with a new feature called streams. Streams are very similar to Kafka streams in that there's a stream of events, so this infinite list of events, and consumers can pull events off and then process them and handle them. So initially, I did an experiment inside of Kick to try to model queues as these streams, and it didn't really work out. It turned out that not everything was possible. Scheduling and uniqueness and all these different things, these advanced features, they weren't possible. And so that's what led to starting Oban. And Oban is built on top of Postgres. I had recognized that all the features that we wanted from streams were actually totally possible in a relational database, and particularly in Postgres. And so spiked to get that started. Starting over entirely with a new database backend meant that we'd have the same exact situation with all these possible regressions, and all of the hardship and production bugs that we ran into before. And that seemed really less than ideal. And about this time, I had started reading the proper testing website that Fred had put up, and then which led eventually to his book. So I grabbed the book, read through the book, and I was very excited about property testing. Started following along with the stream data library, and it seemed like a very promising way to avoid these pitfalls of trying to go recreate examples, very complicated examples, to handle concurrency problems and these hard problems that we would normally deal with. And so property testing, and this talk is about applying property testing and recognizing properties and using them to harden your applications. It's not going to be about all of the different techniques or the generators or in-depth about the libraries at all. But if you have no experience with it, you need to only recognize two different terms, properties and generators. So properties are also the tests. Those are aspects of code that hold true for a random set of data. And random is really the important part here. That's what makes it not an example. That's what makes it a property. The other part is generators. Generators are what generate that randomized set of data. They do it dynamically and infinitely, which allows you to express really complex domains in a small amount of code, but have infinite or virtually infinite examples, or as long as you're willing to tolerate recording something. So that started the process of throwing away all the example tests that had been used in Kick, starting with Oban with a fresh library in a fresh test suite and a single property test. And the goal of the property test was to show that we had reliable execution. The first thing to recognize for our property, and a property you could also say is an absolute. And to identify the important parts of the things that we want to test, we just have to answer this question. So for a background job library, what is the absolute? It's that all inserted jobs are attempted at least one time. So I put a job into a queue, it should be tried. That means it runs, whatever code was inside it runs, and we can tell afterwards that it was run. So we're going to jump into a property. This is all it is. This is all it started as. There are some things that are assumed, but we could write it the way we wanted it to work. The idea is we generate, and this check all, that is a generator as part of stream data, and we can generate a list of jobs. And jobs, here we are defining a generator for it. They're little change sets, and inside of the change set, we have a unique reference, so we can identify any particular job that runs, and we have a list of queues. We assume all these queues are going to be running, and we put a job into it, and then we can check that, yes, they all got inserted, they all ran, and then the status was updated in the database, the timestamp was recorded, the attempt was recorded, and we can verify that these things work. Now, initially, of course, this doesn't work. We've defined a few of the modules, but we can tell right away, I'm saying that I said that there should be at least one attempt, and there is not one attempt. So this point could go in, and this is the draw an owl part of everything. Go and define what the queues are, what the supervision tree looks like, how the configuration works, and make all those things work. But I didn't have to modify this top level test to make that happen. So got those things working, that simple little test, and now it runs 100 different properties, 100 different variants of all of these different jobs in all of these different queues, and they work reliably every time. So that was very simple, but there's a lot more state that happens in running the system. And those are things that are additional absolutes that we can check within the same property. And a few of those are shown here. We expect that not every job is going to work. Sometimes there'll be failures. And if there are failures, we want it to retry. We want to know what those failures were and have them recorded in some way. And if there aren't any more attempts possible, then we want to get rid of them. We want to discard the job and stop it running. So inside of there, we have this, what looks like a very complicated case statement. Yeah, remember, it is verifying all of the behavior for our entire queue system. We can focus in within retriable. So these three assertions verify that same bit. It's scheduled in the future. There's at least one error recorded in the job. And we have a little bit about the pattern. Now, this is where it is a property and not an example. We're not asserting that the error looks like anything in particular. We're saying that errors always has at least one error, and it has this shape to it, and that error will show which attempt it was. And then to fill that, we have to make the generator a bit more complicated. The important addition here is that now we have different actions. So the actions show what should happen when the job runs. Inside the worker, it matches on that with a similar case statement to what we saw before. And it does something like throw an error on purpose, start a task and fail, crash, do something that would happen in a real life system, but it doesn't randomly. We could generate a sequence of jobs that are all errors, but they should still attempt. It should never crash our supervision tree or bring down our producer, and it should keep pulling in new jobs and running. So that enhancement allowed us to develop all of the initial library code. So one generator, one semi-stateful property test, and anybody who really has done work with property testing will recognize that that is not truly a stateful property test. Those don't exist in stream data, but this gets us close enough for the purpose. And there are other little tests that were in there, but this is anytime that there's a modification or something happens, this is the test that I go back to and make sure this one runs first. If that runs, I know that whatever refactoring happened is still okay and that it will work for other people. So after Oban was released, it started getting more recognition. I started writing blog recipes. And the first blog recipe I wrote was about unique jobs. And in the recipe, it showed a few solutions, partial index or putting code inside of your own application. And those were kind of leaky, but it also meant that people had to rely on their own implementation of something, and it wouldn't be guaranteed or verified. And so it seemed like a really ideal candidate for something to be included inside of Oban. And so going back to our mantra kind of question, what is absolute about unique jobs? That duplicates are never inserted. And this is the important part, regardless of concurrency. Now, if we only had one thread or one connection running one transaction at a time, this really wouldn't be very tricky. Where it does get complicated is when you have 2, 5, however many processes and transactions trying to create something at the exact same time. So we can start off with the property, and this is the actual property that verifies this, that gets modified as needed. And again, we have a generator statement. It's generating a bunch of different arguments and runs. And the runs says what the concurrency level should be. So they have a minimum of 2 and a maximum of 5. The maximum could really be anything else, but anything greater than 2 is sufficient to actually have this fail. And here are our generators. Generators are really easy. They generate valid JSON maps. And this is really important because we care that for uniqueness, we have all kinds of random different data. It can't just be that we're checking an ID key or that it is an empty map or something. It has to be this very complex bit of real world-ish kind of data. And then we run this function just to uniquely insert them. And this is really all that is. It just declares that it's unique and tries to insert. And then inside of the body, we start multiple different tasks at the same time. And so they have enough variance that they will overlap and the transactions will conflict with each other. And running through that and then waiting, we should expect that we only ever have one actual ID, no matter how many tasks we have or what the sequencing of that is. When we run this, we'll see it fails. If we don't have proper handling, we expect there only to be 1 job. We got 4. And above there, we can see the clauses that generated the data. And even with a parallelism of 2, we still got 4. And so went in and using some Postgres features like advisory locks and transactional controls and some hashing prevented concurrent writes. We come back to the property, run it again, and it runs very quickly and has no problems. So in this case, for uniqueness, we did 3 generators, 3 small generators, 1 property test, and 2 to n concurrent inserts. And the concurrency, we could tweak to anything, but again, anything over 2 is sufficient to show this. And where a generator really shines, or a property test really shine for this, is that there's a fuzzing aspect of it as well. We could do just 2 threads in kind of a loop, or 2 processes in a loop, and get similar verification, but we wouldn't have that randomization of the data. And so since this was released, it's had 0 reported bugs, aside from 1 issue with namespacing and prefixes, although almost nobody uses that. So I feel pretty good about that. So as Oban had new features released, it started to require more and more data changes. So it uses a system of progressive migrations, which means I can migrate up to a certain version, say 1, and then a new library version comes out, and that provides additional migrations. And that migration might add tables, columns, functions, triggers, indexes, things that are, refinements or enhancements or additions. But people were running it in production at this time. And you can't expect that people are going to throw away their own tables or manually deal with conflicts. And so you have all these possible up-down combinations. You don't know where somebody migrated from, or you don't know if they're going to have to roll back after upgrading. So we want migrations in any of these scenarios to work. And so we have to identify what the absolute is to write a property test for it. And that's migrating up or down between any two versions is successful. Migrating up from nothing should also be successful, but we'll get that for free as part of this property. This will look fairly complex, but most of it's just writing something that we can use to reference to do the migration. Now, see, we put the up version to down version, and then we run some migrator stuff. And here's the migration. It's very simple, up and down. And if we try to run this initially, we'll immediately get a duplicate table, duplicate relation. Things break. So it's trying to go from 8 down to 1, doesn't work. And here, go in and try to put some additional checks. Look for correct use of prefixes, make sure that creative not existing is used, write some other more dynamic kind of checks for things like enums that don't have any built-in kind of stuff. We run it again, and it works, but it's really slow. It takes 5.7 seconds to run. We look back at the generator, we'll see this is for version 8, and version 8, it's generating for up possible random integers between 1 and 8, and for down, random integers between 1 and 7. But as I mentioned before, it generates 100 different examples, and that's more than this would possibly generate. So we look at how many permutations are there really. We do this with a little for comprehension, and we find out that there are 56 combinations. 56 is almost half of what, sorry, just over half of what Stream Data was generating. And so in this case, we want the property that holds that it always goes up and down, but we don't have to use a property test to do it. We can still use a for comprehension that just generates all these permutations and runs through it. We do that, we shaved off 4 seconds. Now it runs in 1.7 seconds. So we have one test for up. There's another test for up and down. And we have 120 permutations that it runs through. And we can be absolutely sure that if we add new migrations, it'll automatically be handled. If people are upgrading from some old version from a year ago up till now, that's going to work. And if somebody has to roll back a couple versions, that's going to work. So as Oban had started getting more popular, Dscout, we weren't able to use it yet. There was a big barrier to adoption. And that's because we really depended on periodic jobs. And now initially, there were no periodic jobs because it depended on unique jobs. There are alternatives out there like Quantum, but they don't use a stateful database like Postgres. So they don't have a central coordination layer. And the important part of Oban, or one of the defining characteristics of it, is that you can always look back in the database to see what's there, and we can use that for unique jobs. Well, unique jobs was finally in, and so the only barrier we had now was to be able to handle CRON expressions and to use those expressions to state periodic jobs. But CRON expressions are really hard. This is a real CRON expression. You can go to crontab.guru and it will generate this up there. And they can be pretty ridiculous. They're wildcards, literal values, steps, ranges, just lists of things, and they all should work. There's no reason that we should limit what people can put in there, considering there's so many possible scenarios that people would want. So we can define a single high-level property that will guarantee we can parse any valid expression. So here's that whole property. Our generator, we have a number of different components to the generator, and it's just generating each part of the possible expression plus spaces, which I'll talk about in a minute. And here are our generators. Here are the simple ones, at least. So months are integers, constants. Weekdays are integers or constants. Spaces are either spaces or tabs. Now, initially, this wasn't handled, which is why there's a special space in here. It was just putting everything together with one space. And it turns out tabs are totally legal, and people have their own little bespoken esoteric formatting for cron tabs, and we wanted to be able to support that too. And then we have the far more complex expression. So an expression, it's a wild card or stem, but what's important is I would never be able to exhaustively write all of these. And even this could be extended to be a little bit more wild. You can see the step value, which is the /2. That could be a /3 or a /4, other things that should be valid. And then once we have this data generated, we can go in and just concatenate it and try to parse it. Parsing happens with a bang. We don't have to have an assertion, but we know anything valid will work. So here's without the space handling. You can see it's generating 2 spaces and it doesn't expect that and everything fails. So we got nimble parsec under the hood. And so modifying it's pretty straightforward. And it finishes. There's no database interaction, so it's super quick and we can reliably fuzz it. This is great to prove what valid expressions are. Where we have a different approach is in invalid expressions. So while there is a finite but very large number of valid expressions for a cron tab, there are infinite invalid expressions. For example, the 60th minute, which you can see on the top there. There is no 60th minute, it only goes to 59. But there's no point in testing 60 and 61 and 62 and 120 or any of those things. That would just take a lot more time and be much harder to write as expressions. So in that case, we can fall back to some example tests. And here you can see property testing and example testing put together just to show explicitly what type of thing should not be possible. So we have 1 property for valid expressions, 1 test for invalid expressions, and 1 reported bug, which was solved with the exact change that we showed before around spaces and tabs. And that's it. Really, what it comes down to in libraries and applications is looking for what is the absolute truth. And those are the properties. And once you understand those aspects of the code that should never fail, the properties and the generators kind of come out of that naturally. All the examples that we've shown here are relatively simple. They have to fit on a slide after all, but the same thing can be expanded out greatly to do more stateful tests, more complicated tests. And in fact, inside of dscout, we've used it for generating playlists of arbitrary videos of arbitrary size with arbitrary audio and arbitrary data. And it's a bit slower because it's generating real videos, but ever since that one, we haven't had any strange befuddling FFmpeg issues. It's all worked very smoothly. So a lot of upfront effort was put in there. But once we recognized that any number of videos of any size, of any length, should all work together, all the properties and generators just kind of came together. So I implore everybody to write fewer, more expressive tests. And again, I used a library as an example because it's open source and you can go check out the actual properties and see how they've changed over time. But it's definitely worth employing in your applications too, bringing it to work with you. And just once you recognize it, that's half the battle. So if you want to hear anything more, you can check out getoban.pro. Oban Pro and Web both use generators and properties a lot under the hood. All the plugins and workers are exhaustively tested using the exact same properties that I've talked about here. And that's all. Thanks.
Thanks, Parker, for the presentation. I think now we can move to the Q&A session. I can see we have some questions. So first question is about some, okay, Tonichi is interested in the use cases of property-based testing, which is involving multiple actors? If you could elaborate on that a bit, maybe.
Sure. In the presentation just now, the closest I got to that was multiple tasks. So from the systems perspective, there's no difference between a task and a particular person. So it's very easy to generate, however many concurrent interactions you happen to want. Made very good use of this. Other places it can be really difficult, especially when you're trying to work with the database inside of your application. If you're using something like the sandbox, everything happens in its own transaction and it gets rolled back, and that can make it very tricky. So if you're going to try to model more complex behavior that's a bit more real world and not as artificially testy, it might be worth it to have some synchronous tests that run outside of a sandbox that you can model as if they're real people with transactions being committed. And then there's a bit more manual cleanup, but it's entirely possible and very simple to do. And I think that's what a lot of the Thomas Arts kind of demos talk about. That's the type of thing that they're trying to show, which is well beyond the scope of what I'm trying to do here.
Cool, thanks. Another question. What are your thoughts on the stream data versus proper, and also follow up with versus quick check?
I've never used quick check. It's proprietary and licensed, and so I've just never gotten into that. But the properties that I show, they actually originally started as proper, or using prop check, the Elixir wrapper around it. And there were problems with that, at least that I ran into. So even though I have stateful properties, it would generate sequences that would then fail. And then it would cache those sequences and they would get stuck. And I would have to go in and manually clean them up. And other things like being able to set up and tear down. It's not integrated into XUnit. So if you want to set up a supervision tree or a bunch of supervision trees or processes beforehand, you can't do that. So you have to wrap that inside of your prop check block and start it and stop it all at the same time. And I found that stream data just worked nicer. The generators were a bit easier to work with. It was simpler to generate ASCII data or UTF data, and it worked perfectly with setup and teardown blocks, or sorry, on exit blocks. So that, I don't know, once I moved there, I just haven't really looked back.
Cool, thank you. Mikael is asking, from what I understand, stateful property-based testing is still not supported by stream data. If this is still the case, is there something you can see as an important missing feature?
Yes, there is a library by, and I'm sorry, Holith. I don't know what his actual, Lucas Jan Desmer, I think is his name, which is called Stream State, I think, which hasn't gotten much use, and honestly I haven't managed to implement it, but it replicates some of the stateful side of things. That said, I think it's easy enough for most situations to do it yourself if you really need that. But I think inside of Dscout's code base and inside of Oban's code base, there are only semi-stateful property tests, and I haven't really felt the need too much for something.